Welcome to Maths for You channel. Another past question on finding the root by iteration from Oxford and Cambridge past paper. The question has a diagram given. It's a graph. The diagram shows a part of a graph fx equal e to the power x divided by 4x squared minus 1 plus 2. The equation fx equals 0 has a positive root alpha closer to x equal 0.3. Part A, explain why using the sign change method with x equals 0, x equal 1 will fail to locate alpha. Part B, show that the equation fx equals 0 can be written as x equal 1/4 square root of 4 minus 2 e to the power of x. Part C, using the iterative formula xn plus 1 equal 1/4 square root of 4 minus 2 e to the power of xn with the starting value of x equal 1 equal 0.3, x1 equal 0.3, to find the value of alpha, the correct 4 significant figures showing the result of each iteration. The alternative iterative formula is xn plus 1 equal fxn, the function of fxn, where fxn equal ln2 minus 8xn squared. By considering f dash 0.3 as xn 0.3, explain why this iterative formula will not find alpha. Okay, let's start with the question. Fx equal e to the power x divided by 4x squared minus 1 plus 2. I just resketch the diagram or graph. It will not help us, just for info. What we need to do, the sign change will not locate alpha. So there are two signs given. So we need to find the sign of each value, the given value. And if the sign changes, it will locate the root. Here, let's see. The given values are 0 and 1. So f0, e to the power 0 divided by 4 times 0 minus 1 plus 2. That is minus 1 plus 2 equal plus 1. That is greater than 0. And then f1, e to the power 1, 4 times 1 minus 1 plus 2. That is greater than 0, 2. So the sign not change. If the sign change, of course we can locate the root. But here, both signs are positive or not change. Therefore, not locating it fails to locate the alpha. So no change of sign of fx between x0 and x1. So that's the answer for first part. B, so the equation fx equals 0 can be written as that, right? Okay. Fx equals 0, fx is e to the power x, 4x divided by 4x squared minus 1 plus 2 equals 0 as the equation. So so e to the power x over 4x squared minus 1 equal minus 2. Take the 2 to that side. From that, e to the power x equal 8x squared, cross multiplication, minus plus 2. So 8x squared, this is what we have to find, x equal. 8x squared, 2 minus e to the power x squared equal 2 minus e to the power x divided by 8. In the answer x, 104. So the denominator is 16, but we have 8. So let's we can multiply 2 by 2, the denominator and the numerator. So x squared equal 2 over 16. 8 times 2 is 16. And what we have in the denominator is 2 minus e to the power x. Then take 2 inside. So 1 over 16, 2 times 2 is 4, minus 2 e to the power x. From that, x equal 1 over 4, square root of 4 minus 2 to the power ex. But obviously, plus or minus minus x equal. But we looking for the positive, just a positive root we're looking for. So therefore, just ignore that negative. It may not be negative, but just leave it at the moment. So positive. So x equal 1/4 square root of 4 minus 2 e to the power x. That is what we have been asked to prove, and we did. Again, as the equation given to find the root by iteration, xn plus 1 equal 1/4 square root of 4 minus 2 e to the power xn. That's what it is. So just to, right, the x1 is given 0.3. So starting from n equal 1, x2 equal 1/4 square root of 4 minus 2 e to the power of 0.3, because xn equal 0.3. x1 equal 0.3, sorry, x1 equal 0.3. And to the calculation, and the value we are getting 0.28507. Then n equal 2, x3, 1/4, 4 times 2 e to the power x2. I just put x2 rather than put in the long value. Then value is found is 289.28943. And n equal 3, x4 equal 1/4, and the same pattern, and the answer is 0.28817. So if you, it's just going down from the first part, right? Okay, n equal 4. The answer is 2.28853. n equal 5, the answer is 0.28843, slightly going down. And then the n equal 6 is 4, square root of 4 minus e to the power x6, x6. And again, the answer is 4, 6, slightly going up. And n equal, so it was 5, 3, and 4, 3, and 4, 6, sort of gone down and gone up again, slightly going up. So n equals 7. Then the answer is, it just is 0.285, so coming down again, 0.28845. But I just wanted to make sure this is actually stick to that value. N equal 8, that is 0.28845. So the iterative method, that the value, the root is staying now, just come to a finite value. So alpha equal 0.28845 because of 45, but they ask us to ask the answer in correct to 4 significant figures. So that means 4, 5 is 5. So 0.2885. That's the answer. The next one. So the xn plus 1 given, another iterative method, for xn, for fxn. So fxn is given ln 2 minus 8xn squared. And then they gave us the f dash 0.3. So just before that, let's differentiate. F dash xn, differentiate this function, and the differentiate. It's log function, so 1/2xn squared times, and then what's in the bracket, 2 minus 8, differentiation at 2 minus 8x squared, 2 is 0, 8xn squared, that is 8 times 2xn. So simplified, minus 8xn, and 1 minus 4xn squared. So f dash 3.3, then substitute the value for xn, minus 8 times 0.3 divided by 1 minus 4 times 0.3 squared. That is calculator work. That gives us minus 3.75, right? The f dash 3, that is the gradient. So it's a modulus f dash 0.3, or modulus the value of f dash 0.3 is 3.75. That is greater than 1. So therefore, the iteration will diverge than converge. So we need to converge to get the finite value. But this is actually go away from the actual value. That means, so the diverge than converge, that means each iteration would move away from the expected value of closer to 0.3. Therefore, this method will not find us the value of alpha. That's what they ask us to find and explain. Thank you. Please subscribe the channel and share the contents with your friends and other students. Thank you.